classified according to their chemical structure. The synthesis, secretion, and transport of hormones depend on the chemical properties associated with structure. The control of secretion of hormone depends on its function.
Так, вот посмотрите, как по-разному действуют. Я вам как говорила, одни действуют на что? На проницаемость клеточных мембран, другие действуют на проницаемость непосредственно самой клетки, да? И третьи действуют как стероидные внутри на само ядро, на транскрипцию, как говорится, и продукцию уже синтеза. Вот теперь смотрите. Ну да, уж пока дается так просто название.
Your goals for learning are to recognize the chemical classes and solubility properties of hormones, to observe how a single member of each class of hormones is synthesized, to know that secretion of hormones depends on release, synthesis, or both, to learn that neural, hormonal, or humoral stimuli control secretion of hormones. Here's what you need to know. The structures of amino acids, proteins, and steroids. The difference between water-soluble and lipid-soluble. The concept of negative feedback systems and how they work. The synthesis of complex molecules proceeds along pathways, each step requiring a specific enzyme. The anatomy and neurotransmitters of the autonomic nervous system. To see definitions of terms, click the bold red words. Recall that a hormone is a chemical messenger that is released into the bloodstream. Most hormones can be grouped into one of three classes of chemicals: peptides, amines, and steroids. Click the word peptides. Hormones made from chains of amino acids range in size from small peptides of just 3 amino acids to small proteins containing more than 20 amino acids. For simplicity, we will refer to all of them as peptides, a convention used by endocrinologists. Most hormones are peptides. They are water-soluble. We will study synthesis of the peptide insulin in detail in the next pages. Click the word amines. Amine hormones are derived from the amino acid tyrosine. Dopamine, norepinephrine, and epinephrine are called catecholamines. They are formed by a series of chemical reactions that modify tyrosine in successive steps. Catecholamines are water-soluble. We will study the synthesis of epinephrine in detail in the next pages. 2 iodine-containing molecules, thyroxine, or T4, and triiodothyronine, or T3, jointly form the thyroid hormone. Each is produced as iodine is added to thyroglobulin. T4 and T3 are soluble. We will study the synthesis of thyroid hormone in detail in the next pages. Steroid hormones are derived from the molecule cholesterol. Steroids are formed by a series of chemical reactions that modify cholesterol in successive steps. Steroids are lipid-soluble. We will study synthesis of the steroid cortisol in detail in the next pages. We will now study synthesis of the peptide insulin. Recall that insulin is produced by beta cells in the pancreas. Click the rough endoplasmic reticulum to begin. Peptide hormones are synthesized on ribosomes often as large precursor molecules called preprohormones. Many are processed in the endoplasmic reticulum into smaller peptides called prohormones. Click a preprohormone in the rough ER to see the prohormone for insulin. The Golgi apparatus packages the prohormones with other proteins into secretory vesicles that are stored within the cell. For some hormones, conversion to the active form takes place in the vesicles. Click a prohormone in the secretory vesicle to see. Drag a secretory vesicle to the plasma membrane. The synthesis and storage of amine hormones varies for each hormone. Recall that epinephrine is produced in the adrenal medulla of the adrenal gland. Click the molecule to begin the step. Cells of the adrenal medulla are modified postganglionic neurons of the sympathetic nervous system. Like postganglionic neurons, they are innervated by preganglionic sympathetic fibers and they produce catecholamines. Unlike postganglionic neurons, the adrenal medullary cells lack axons and secrete their products into the bloodstream for dispersal. In most postganglionic neurons, norepinephrine is the primary catecholamine and it functions as a neurotransmitter. In adrenal medullary cells, epinephrine is the primary catecholamine. Because it enters the bloodstream, it functions as a hormone. Click the molecule to continue. Synthesis of epinephrine begins as tyrosine is converted to dopamine. This conversion takes place in the cytosol where the enzymes for each step are located. Dopamine is pumped into secretory vesicles called chromatin granules, where the enzyme for conversion to norepinephrine resides. Click the secretory vesicle to continue. Both norepinephrine and epinephrine are produced by the adrenal medulla in a ratio of 1 to 4 or 1 to 5. Production of epinephrine requires norepinephrine to re-enter the cytosol, where it is converted to epinephrine. It is then pumped back into the vesicle. Secretory vesicles serve two purposes. They amass quantities of catecholamines for rapid release, and they protect norepinephrine and epinephrine from breakdown by cytosolic enzymes. Click the secretory vesicle to continue. Hormones are released from adrenal medullary cells by the same process that causes release of neurotransmitters from neurons. Stimulation of both endocrine cells and neurons causes an influx of calcium that induces movement of the secretory vesicles to the plasma membrane. They open and release their contents into the extracellular space by exocytosis. Since they are water-soluble, catecholamines are carried in the blood plasma as dissolved particles. To see the entire sequence, click a secretory vesicle. Recall that the thyroid gland produces thyroid hormone. The mechanism of production of this amine hormone is unique in the body. Click a molecule to begin the step. Recall that thyroid hormone is really two molecules, T3 and T4, produced by special follicle cells that surround spherical structures called follicles in the thyroid gland. Production begins as follicle cells synthesize a protein called thyroglobulin and secrete it into the follicle. The protein contains multiple copies of the amino acid tyrosine. Click the thyroglobulin to continue.
Куда?
Нет, Серегу, блин, ладно.
Нет, ты...
The synthesis of steroids from cholesterol creates a large family of related hormones. The type of enzymes present in a given cell determine which steroid or steroids that cell produces. The metabolic pathways are very complicated and contain more intermediaries and loops than are illustrated here. Click cortisol to begin.
Там, где клик нажимаете.
Вот рядом.
Recall that cortisol is produced by the inner portion of the adrenal cortex.
Там, где клик, там надо нажимать.
Adrenal cortical cells store a modified form of cholesterol in lipid droplets. Synthesis begins as cholesterol is released from storage. The critical step in converting cholesterol to any steroid hormone is production of the common precursor molecule, pregnenolone. Enzymes for the production of pregnenolone reside on the inner mitochondrial membrane. Cholesterol enters the mitochondrion where it is converted to pregnenolone. The pregnenolone molecule must re-enter the cytosol for conversion to intermediaries on the pathway to cortisol production. Intermediaries re-enter the mitochondrion where they are converted to cortisol. Click the cortisol in the mitochondrion to continue.
Нажимаете, там есть клик.
Cortisol enters the bloodstream by diffusion. The lipid-soluble cortisol and other steroids bind to two kinds of carrier proteins. Specialized carriers that bind particular steroid hormones, and the plasma protein, albumin. Remember that albumin non-selectively carries many lipid-soluble hormones. Steroid hormones are not stored. They are synthesized on demand. Therefore, the secretion of steroids is immediate, and its rate depends on the rate of synthesis. To see the entire sequence again, click on the cholesterol.
Что такое генная транскрипция? Под действием АТФ и АДФ, да, идет что? Синтез белка. Так, давайте дальше.
Ты еще не закончил?
Не закончил? Так вы можете перевести картинку. Нажимаете дальше.
We have learned that the availability of hormones depend on their secretion. Stimuli may alter synthesis, relief. Blood levels of a given hormone can vary widely over the course of a day. Normally, blood levels are determined by
Какое
secretion.
количество плазмы?
Hormones are not
Переходите дальше.